Hello there, and welcome to the Sleepy Science Secret. Tonight, we are going to drift into one of the most quietly astonishing questions that has ever existed. One that philosophers and scientists and dreamers have turned over in their hands like a smooth river stone for centuries. Why does time only move in one direction? Why can you remember yesterday but not tomorrow? Why does a candle always burn down and never up? The universe, it turns out, keeps a secret about this, and the secret is woven into the very fabric of everything, into every breath you take, every star above your head, every soft moment just before sleep. The answer is not frightening. It is, in the most gentle way, beautiful. So let your shoulders relax now. Let your eyes grow a little heavy, and let time carry you slowly, softly, into the night. There is a river that has been flowing since the beginning of everything, and you have been floating on it your whole life without ever once having to think about it. That river is time, and tonight, as you rest, we are going to let its current carry us, not forward with urgency, but slowly, the way a leaf drifts on still water, turning and turning without hurry. Time is one of the oldest mysteries there is. Long before telescopes or laboratories, people looked at the sky and noticed that the sun always rose in the east and set in the west. They noticed that seeds became trees, that rivers carved valleys, that people grew old. Something was always moving in one direction, and for most of human history, people simply accepted that this was the nature of things, that time flowed like a river, always forward, never back. But here is a fascinating and peaceful thing to consider. The laws of physics, at the very smallest and most fundamental level, do not actually require time to move in any particular direction. If you filmed two electrons bouncing off each other and then played the film backwards, nothing about that tiny collision would look wrong. The mathematics that describes it works equally well in either direction. This is one of those quiet, wonderful surprises that science sometimes offers. The universe, at its smallest scale, does not care which way time goes. And yet, here we are. Here you are, breathing in, breathing out, moving through the evening toward sleep. And time is clearly going somewhere. The past is behind you, solid and finished. The future is ahead, soft and unformed. Something is giving time its direction, and that something turns out to be one of the most elegant ideas in all of science. That idea has a name. It is called entropy. You may have heard the word before, but tonight we are going to hold it very gently, the way you might hold a feather and look at it in the warm light. Entropy is simply a measure of disorder, of how spread out and mixed up things have become. And the universe, quietly, without any effort or intention, is always moving from less disorder toward more disorder. Think of it this way. Imagine you have a box divided in the middle, and on one side there are 1,000 tiny particles all packed together, and on the other side there is nothing, just empty space. If you remove the divider, where do the particles go? They spread out. They fill the box. They do not stay neatly in one corner. They do not arrange themselves into a perfect pattern. They simply spread, the way warmth spreads through a room, the way the smell of something baking moves through a house, soft and inevitable. That spreading is entropy increasing, and it almost always happens in one direction. Not because there is a rule that says the particles cannot go back. Technically, they could, but the number of ways for them to be spread out is so enormously, almost incomprehensibly larger than the number of ways for them to be neatly packed together, that randomness alone makes spreading the overwhelmingly likely outcome. There is something deeply restful in this idea if you let yourself feel it. The universe is not trying to do anything dramatic. It is simply exploring all the ways things can be arranged. And because there are so many more arrangements that look like disorder than arrangements that look like order, disorder is what tends to grow. This is why your morning tea cools down, but never spontaneously heats back up. The heat from the tea spreads into the surrounding air, and the air molecules carry it away in 1,000 different directions. And the chance of all those molecules returning at exactly the right moment to give all their energy back to the tea is so small it might as well be zero. This is why dropped glasses shatter, but shattered glasses do not reassemble. This is why a sandcastle slowly crumbles, but the sand on a beach does not spontaneously arrange itself into a castle. In every case, there are simply more ways to be broken than to be whole, more ways to be scattered than to be gathered. And here is the quiet miracle at the heart of all of this. The direction in which entropy increases is the direction we call the future. The past is where things were more ordered. The future is where things become less ordered. And time, as we experience it, flows from one toward the other. Physicists have a name for this. They call it the thermodynamic arrow of time. It is the reason you have memories of yesterday and not of tomorrow. It is the reason you feel as though you are moving forward through time and not backward. It is, in a sense, the reason there is a story at all, because stories have beginnings and middles and ends, and beginnings are the ordered parts, and endings are where things have spread and changed. Let your breath slow just a little as you take that in. You are riding the arrow of time right now, carried forward on the gentle current of increasing entropy, moving from the slightly more ordered moment of this afternoon toward the beautiful, restful disorder of deep sleep. And if that feels like a strange kind of comfort, it is, because it means that sleep itself, that soft unraveling of consciousness, is, in a way, the universe doing what it always does, spreading, relaxing, letting things be as they naturally want to be. If you are enjoying this gentle journey through science, do leave a comment below and let us know what topics you would like to explore next. And if this helps you find a little peace at bedtime, a like would mean the world to us here at Sleepy Science. There is a physicist who once said that time is what prevents everything from happening at once. He said it almost as a joke, and yet it contains something true and rather beautiful. Time is the spacing of things. It is the gentle distance between one moment and the next, the pause between a thought and its consequence, the soft interval between a star being born and a star going dark. We left off with the idea of entropy, that beautiful, unhurried tendency of the universe to spread and mix and let things settle into their most likely arrangements. And tonight, we continue drifting along that current, picking up more of the story, one soft detail at a time. One of the earliest people to think seriously about time's direction was a physicist named Ludwig Boltzmann. He lived in the 19th century, a large and passionate man who loved music and long walks and the company of ideas. He was one of the first to understand that the laws of thermodynamics, the laws governing heat and energy, were really statistical laws. They were not absolute rules like the ones that govern a billiard ball rolling across a table. They were more like the gentle, inevitable truths that govern crowds. Imagine a crowd of people leaving a concert hall. You can say with great confidence that they will spread out into the streets, moving away from the hall in all directions. You could not say exactly where any one person would go, but you could say almost certainly that they would not all spontaneously gather back together in front of the hall at midnight. The crowd behaves in predictable ways, not because any rule forbids returning, but because there are so many more ways to be spread out than to be together. Boltzmann saw that atoms and molecules behave exactly like this. A gas in a container left to itself will settle into the most likely arrangement, which is a roughly even spread throughout the container, not because a rule says it must, but because the number of arrangements that count as evenly spread is almost infinitely larger than the number of arrangements that count as all bunched up. He spent much of his life working on this idea, writing it out in beautiful and painstaking mathematics, and it is one of the great foundations of modern physics. His formula for entropy, which connects the disorder of a system to the number of possible arrangements its parts can have, is so important that it is carved on his gravestone in Vienna. A man whose deepest insight about the universe is written in stone, in the quiet of a cemetery, which is itself a kind of ordered place, a still place, outside the rush of time. Boltzmann's work helped explain why heat flows from hot things to cold things and not the other way around. A hot object is one where the molecules are moving quickly, jostling and vibrating with energy. A cold object is one where they are calmer, slower. When they touch, the faster molecules knock into the slower ones and share their energy. The energy spreads out. Things become more evenly distributed. Entropy goes up. And the whole process happens in one direction, from hot to cold, because that is the direction of increasing entropy, which is the direction of time. There is something almost meditative about this. Everything in the physical world is constantly doing the same quiet work, spreading energy more evenly, mixing things more thoroughly, settling into the most probable arrangement. The wind that moves through trees at night is part of this. The warmth you feel from a blanket is part of this. The way sound gradually fades and is absorbed by walls and curtains, that too is entropy at work, energy spreading out, the universe relaxing into stillness. And here is a thought to carry with you as you drift closer to sleep. Your body, right now, is doing something extraordinary. It is maintaining order in a world that constantly tends toward disorder. Your cells are keeping themselves organized, repairing small damages, managing temperature, cycling energy. This is what life is, in a physical sense. A temporary, beautiful resistance to entropy. A small eddy in the river where things stay ordered for a while before the current takes them on. This makes life itself a kind of miracle of physics. Not a violation of entropy. You still produce heat. You still exhale carbon dioxide. The entropy of the world around you still increases. But inside you, for this precious time, things stay ordered. The story goes on. Now, there is another way to think about time's direction, one that does not come from thermodynamics, but from cosmology, from the study of the universe as a whole, its size and age and origin. This is the cosmological arrow of time, and it is connected to an astonishing fact. The universe had a beginning. About 13.8 billion years ago, everything that exists was compressed into a space almost unimaginably small and hot, a state of such extraordinary order and energy that it stands as the lowest entropy moment in all of cosmic history. This is the Big Bang, not an explosion into space, but an expansion of space itself, carrying all the matter and energy of the universe outward, spreading, dispersing, cooling over the long, slow billions of years that followed. The universe has been on a one-way journey from that moment of extreme order toward the vast, diffuse, eventual coolness of its far future. And we are in the middle of that journey. Stars are still burning, galaxies are still spinning, life is still possible. But everything is moving in one direction, toward the dispersal of energy, the cooling of stars, the gradual darkening of a universe that has spent all its initial order. The fact that the past had lower entropy than the present is ultimately traceable back to that initial moment, to the extraordinary, almost impossibly ordered beginning. Why the universe began in such a state of low entropy is one of the deepest unanswered questions in physics. Some physicists say it is simply a feature of the initial conditions, something we accept without explanation. Others suggest it might be connected to a deeper structure of reality we have not yet found. But for tonight, let it simply be a source of wonder. You are here, breathing softly in the dark, because the universe began in an extraordinarily ordered state and has been gently unwinding ever since, like a music box whose spring was wound very tightly at the start and is still, very slowly, releasing its stored energy into the world. Do check out our playlist of other Sleepy Science episodes. There are stories there about stars and oceans and the mathematics of snowflakes, all waiting for you on quiet evenings like this one. The night outside your window, if you can imagine it, the deep, wide, quiet night, is full of light that has been traveling for a very long time. Some of it left its star a few years ago. Some of it has been crossing the dark for millions of years. And all of it is moving in one direction, from where it was born toward where it will eventually be absorbed. Light, too, has a relationship with time's direction, and it is a beautiful and surprising one. When physicists first worked out the equations describing how light and electricity and magnetism behave together, the work of a Scottish physicist named James Clerk Maxwell, done in the 1860s, they discovered something unusual. The equations had two kinds of solutions. One described waves of light traveling outward from a source, like ripples from a stone dropped in still water. The other described waves traveling inward toward a source, as if light were flowing in from everywhere and converging on a single point. We never see the second kind of thing happen. We never see light flying in from all directions and converging neatly onto a single candle flame, making the flame absorb light and grow brighter. Candles send light out. They do not gather it in, and yet the mathematics would allow it. Why does the universe choose only one of these two solutions? Once again, the answer comes back to entropy. Light radiating outward from a source increases entropy. It spreads energy into the surrounding space. Light converging inward onto a source would decrease entropy. And since entropy is always going up, the outward radiation, is the one that actually happens. Time's arrow once again gently points in only one direction. There is a physicist named Richard Feynman who described this beautifully. He said that the laws of physics are like a game where all the moves are reversible. Any film of any physical process, if played backwards, would still show something physically allowed. But the universe, at the large scale, does not choose to play the film backwards. And the reason it does not is ultimately connected to that low entropy beginning, to the extraordinarily ordered state from which everything emerged. You might wonder, if the laws of physics allow time to run backwards, could there be parts of the universe where it actually does? Could there be regions where entropy decreases, where tea grows hotter on its own, where broken things reassemble? This is not just a science fiction idea. Some physicists have genuinely considered it. And the answer that most of them arrive at is subtle and a little wonderful. Locally, in small places for short times, entropy can decrease. That is exactly what happens in living things. We maintain and increase local order while exporting disorder to the environment. But in larger regions and over longer times, entropy always increases. The direction of time, as we experience it, is a large-scale statistical truth, not a small-scale absolute one. Think of an eddy in a river. The water in the eddy seems to be going backwards, circling and swirling against the main current. But the river as a whole still flows downstream. Life is something like that eddy, a beautiful, temporary reversal of entropy's local tide, embedded in a universe that is, on the whole, flowing only one way. There is another way to think about the arrow of time, one that comes not from physics, but from information, from the structure of memory and knowledge. This is called the epistemic or psychological arrow of time, and it is, perhaps, the most intimate arrow of all because it is the one you feel most directly. You remember the past. You do not remember the future. This seems so obvious that it barely seems worth saying. But why should it be true? Why does information about past events get recorded in your brain while information about future events does not? The answer is connected, again, to entropy. For a record to be made of an event, something has to change. Neurons have to fire, patterns have to form, energy has to be spent. This process requires the system doing the recording to start in an ordered state. Your brain, before it stores a memory, has to be in a ready, organized state. The act of remembering uses up some of that order, increases the local entropy slightly, and in exchange creates a lasting trace of what happened. This is why memories always point backward. The process of forming them requires an ordered system and a causal connection to past events. The future has not happened yet, and so there is nothing to leave a trace. The information does not exist to be recorded. Let your eyes rest now. Let the room be quiet. The memories of today are settled into you. The soft facts of the morning, the texture of the afternoon, the moments that arrived and were gently stored. All of that is behind you now, ordered and fixed. And what is ahead is still unwritten, still possible, still light. There is a clock at the top of a tall building and a clock in a basement, and they tick at different speeds. The one at the top runs slightly faster. The one in the basement runs slightly slower. This is not a malfunction. It is not a metaphor. It is simply how time works in a gravitational field. This is one of the most dreamlike and true things in all of physics. Time is not a fixed background against which events happen. Time is something that can be stretched, compressed, curved. It flows differently depending on where you are and how fast you are moving. And this fact comes from a theory that changed the way we understand everything: Einstein's general theory of relativity. Albert Einstein spent years thinking about time, not as a river with a fixed channel, but as something more like a fabric, soft and flexible, responsive to the massive things within it. A planet, a star, a black hole. All of them dimple the fabric of time and space, creating what physicists call space-time curvature. And in curved space-time, time flows at different rates. This is why time passes slightly faster for the GPS satellites orbiting the Earth than it does for the clocks on the ground. The satellites are farther from Earth's gravitational field, which is slightly weaker up there, and so time runs slightly faster for them. If engineers did not correct for this effect, the GPS system would drift out of accuracy by several kilometers per day. So, time itself, the thing that seems most fixed and universal, the steady tick that feels the same whether you are happy or sad, old or young, turns out to be local. Your time is yours. My time is mine. They agree very closely because we are in similar gravitational fields and moving at similar speeds. But in the deep sense, each of us carries our own little river of time flowing at our own rate. There is something that this does not change, though. No matter how fast or slow your time runs, it still runs forward. The relativistic distortions of time are real and measurable, but they do not reverse time's direction. Even in strong gravitational fields, entropy still increases. Broken things still do not reassemble. The past is still the past. The arrow of time is not erased by Einstein's theory. It is, if anything, made more subtle and beautiful by it. There is a concept in relativity called the light cone. Imagine yourself at a single point in space and time, right here, right now. A light cone is a way of drawing all the places light could reach from where you are, spreading outward in all directions. Everything inside your future light cone can be influenced by you. You could, in principle, send a signal there. Everything inside your past light cone could have influenced you. A signal from those times and places could have reached you. And everything outside your light cones is simply disconnected from your present moment, neither causing nor being caused by you right now. The light cone is a gentle way of imagining the structure of time as a real, physical thing, not an abstraction, but a geometry, a shape that you carry with you through the universe, defining what is past, what is future, what is present. And as you carry that shape through the night, as you breathe and slowly let the day dissolve, your light cone is moving steadily forward, leaving behind the world of this evening and carrying you toward the morning. You cannot go back into it. You cannot revisit this exact moment. It is right now becoming the past, becoming fixed and ordered and finished, settling into the great stillness of all the moments that have already been. There is something in that which is not sad, but peaceful. The present is always becoming the past, and the past is always safe. It has already happened. It is already complete. There is nothing more for it to do but rest. Somewhere above the city tonight, if the sky is clear, there are stars visible that burned out before humanity existed. The light you see from them left before there were eyes to see it, and has been traveling across empty space ever since. It is arriving now, at this moment, completing a journey of thousands of years, past light, still landing, still warm in its tiny way. Time does not erase things. It carries them forward. The light of old stars, the memory of kind days, the warm feeling of an evening spent in quiet company. These things do not vanish. They become part of the structure of what has been. They settle into the past like stones into still water, permanent in their way, completed. If you feel the pull of sleep, let it come. These thoughts will still be here tomorrow, changed a little by the night, settled a little deeper, the way all things are. That is entropy too. The way ideas spread through you slowly, mixing with everything you already know, becoming yours in a way they were not quite yours before. When you imagine the universe as a whole, when you try to hold in your mind the entire 13.8 billion years of it, from its extraordinary ordered beginning to whatever quiet ending it may have, you are doing something that no human being was able to do before the last few hundred years. The scale of it is so vast that we need new numbers just to talk about it. There are roughly 2 trillion galaxies in the observable universe. Each galaxy contains, on average, about 100 billion stars. And each star may have planets orbiting it, planets where, on some of them, the conditions might be just right for the same extraordinary accident that happened here, the emergence of life. Life, as far as we know, is the universe's most sophisticated experiment in local order. And there is a beautiful irony in this. Life exists because entropy increases. The sun pours energy into the earth, and the earth radiates that energy back out into the cold of space. The difference between the concentrated, useful energy coming in and the dispersed, wasted energy going out is what life runs on. We are, in a physical sense, creatures of entropy. We exist in the flow between the ordered sun and the disordered darkness of space, extracting a little work, a little beauty, a little consciousness from the current. This is a fact so quietly profound that it deserves a moment of stillness. You are not separate from the universe's movement through time. You are part of it. The atoms in your body were forged in ancient stars that burned and expanded and scattered their material across space. Some of those atoms became part of the earth, some of the ocean, some of the air, some of the food that eventually became you. You are a temporary arrangement of star stuff, maintaining its order for a little while against the background of a universe that is slowly, gently settling into dispersal. The physicist Brian Cox once described time's arrow as something that emerges from the universe's low-entropy past. He said, and this is a thought worth carrying into sleep, that we remember the past and not the future, because the universe was born in an ordered state. Our memories, our sense of narrative, our feeling of moving forward through time, all of these are, in the deepest sense, consequences of the Big Bang. There is another arrow of time that physicists sometimes discuss, and it is one of the strangest and most wonderful. It is called the quantum arrow of time. Quantum mechanics is the science of very small things, atoms, electrons, photons, and it describes a universe that is, at its most fundamental level, not entirely fixed or determined until something is observed or measured. In the quantum world, particles do not have definite positions or speeds until they interact with something else. Before that interaction, They exist in what physicists call a superposition, a kind of gentle blur of all the possibilities they might have. When the interaction happens, the superposition collapses, and the particle takes on a definite state. And this collapse, the transition from many possible states to one actual state, happens irreversibly. It goes in one direction. It is, in its own quiet way, another arrow of time. The quantum world is full of these tiny, irreversible moments. Millions of them happening inside you right now as your neurons fire and your cells metabolize, and the machinery of life runs its endless, intricate cycles. Each one is a small, definite event, a tick of the cosmic clock, a moment of the universe choosing one path from the many that were available. There is something almost tender in this. The universe is always choosing, always moving forward, always, in the language of quantum mechanics, collapsing its possibilities into actualities. And you, your body, your brain, the warm quiet of your breathing, are made of trillions of these tiny choices, each one irreversible, each one part of the river that moves only one way. Let your breath settle now. Let your thoughts become soft. We will continue drifting together, but there is no hurry. The night is long, and the science is gentle, and we have much more to explore before morning. If you have been listening from the beginning, thank you. Your company on this journey means a great deal. And if you are new here, welcome. Do look through our playlist when you have a quiet moment. There are other nights like this one waiting for you, full of soft and beautiful facts about the universe. There is a type of particle in physics called a kaon. It is a tiny thing existing for only a fraction of a second before it decays into other particles. And it is, in a very specific technical sense, one of the only things in the universe that shows a difference in behavior depending on the direction of time. This is called CP violation, and it was discovered in the 1960s by two American physicists named James Cronin and Val Fitch, who won the Nobel Prize for it. What they found was that kaons, under certain conditions, decay differently depending on whether time is running forward or backward. Not by much. The effect is very small. But it is there. This is significant because it suggests that at the deepest level, the laws of nature are not perfectly symmetric in time. There is a tiny fundamental preference built into the fabric of things, a subtle lean toward one direction. And this lean may be connected to one of the greatest mysteries in cosmology, why the universe contains matter and not antimatter. When the universe began, matter and antimatter should have been created in equal amounts. If they had been exactly equal, they would have annihilated each other completely, leaving a universe of pure energy and nothing else. No stars, no planets, no people breathing softly in the dark, but something, some tiny imbalance in the earliest moments, meant that there was ever so slightly more matter than antimatter. The antimatter annihilated most of the matter, and what was left, the tiny surplus, became everything that exists. That surplus, that tiny leftover of matter, is you, is me, is the stars, is the warm blanket and the night air and all of it. The imbalance that made us possible may be connected to CP violation, to that tiny asymmetry in how particles behave depending on the direction of time. It is not yet fully understood. It is one of the open questions, one of the still unlit rooms in the great house of physics. But the fact that it exists at all tells us something quietly wonderful. The universe has a preference. It leans ever so gently toward the future. Speaking of things that lean toward the future, your body right now is doing something remarkable. Your cells are generating heat, moving molecules, running the chemical processes that keep you alive, and all of this happens in the direction of time. Enzymes catalyze reactions, proteins fold, signals travel along nerves. All of it moves forward. All of it is irreversible in the sense that the exact state of your body 1 second ago cannot be perfectly recovered. Time has passed, and the past is past. There is a physicist named Sean Carroll who has written beautifully about the arrow of time, and one of the things he emphasizes is that the reason we feel time moving forward, the reason we have the subjective experience of past and future, is ultimately traceable to the thermodynamic arrow. Our brains form memories by increasing entropy slightly. Our sense of self, of having a history and a trajectory, is built on this thermodynamic foundation. This means that consciousness itself, the quiet light of awareness behind your eyes, is, in a profound sense, a consequence of the universe's journey from low entropy to high entropy. You exist, you are aware, you have a past and a future, because the universe began in an extraordinarily ordered state and has been gently unwinding ever since. There is something that feels both humbling and wonderful about that. You are not separate from time's arrow. You are not merely riding it. You are, in some deep sense, an expression of it, a particularly intricate and lovely way that entropy can increase, a way that involves looking up at the stars and wondering, a way that involves building things and tending to each other and telling stories in the dark. The dark outside is gentle now. The night has settled into itself. Whatever sounds were present earlier, traffic, voices, the small business of the world, they have quieted. This is entropy too, in its own way. The energy of the day dispersing, the activity of the world slowing, the great spreading of the light's energy into the dark warmth of the night. There is an experiment you can do with a cup of hot tea that contains one of the deepest truths in all of physics. You make the tea, you set it on the table, you wait. The tea cools. The room is not noticeably warmed. But if you were precise enough, if you could measure the air molecules with perfect accuracy, you would find that the room is very, very slightly warmer by an amount exactly equal to the heat that left the tea. Energy was conserved. Not a single unit of it vanished. It just spread. It moved from the concentrated, ordered arrangement of heat in the tea to the dispersed, disordered arrangement of slightly agitated air molecules throughout the room. The total energy stayed the same, but the quality of that energy, its usefulness, its orderliness, decreased. Physicists call this useful energy exergy, and they call the process of useful energy becoming less useful the degradation of energy. It is one of the most important processes in the universe. It is what drives everything, every engine, every living cell, every fire, and every heartbeat. Everything runs on the difference between concentrated energy and dispersed energy, on the tendency of one to become the other. The sun is the great source of concentrated energy for our part of the universe. It burns, converting matter into energy at a rate almost incomprehensible. Millions of tons of hydrogen becoming helium every second, releasing light and heat and a gentle stream of particles called the solar wind. That energy streams across space, some of it reaching the Earth, warming the oceans, driving the winds, powering the photosynthesis that feeds nearly every food chain on the planet. And eventually, all of that energy will be radiated back into space, dispersed, spread thin across the great dark, lost to usefulness. The sun will cool over billions of years. The planets will grow cold. The stars will burn out one by one over timescales so vast they barely have meaning for us. In the far, far future, the universe may reach what physicists call heat death, a state of maximum entropy where no useful energy remains, where everything is the same temperature everywhere, where nothing more can happen, where time, in a practical sense, loses its meaning because there is no more change. This is not a sad thought, not tonight. It is too far away to grieve, and it is also beautiful in its way. The idea that the universe has a story with a direction, that it began in extraordinary order and will end in perfect, absolute stillness. That everything between the beginning and the end is the unfolding of that journey. That we are here in the middle of it, in the warm and complex middle, when the light is still bright and the water still moves and the extraordinary accident of life is still possible. There is a concept called the Boltzmann brain, named after our friend Ludwig Boltzmann. If the universe exists long enough, longer than its current age by a factor so large it defies imagination, then random fluctuations of entropy could, in principle, spontaneously create any configuration of matter, including a brain floating in space with a complete set of memories and experiences that existed for one instant before dissolving back into randomness. This is a thought experiment, not a prediction, but it illustrates something important. Even in a universe of maximum entropy, the past, all of this, all of now, would remain possible as a memory, as a trace, as a fluctuation. The story does not disappear. It just becomes very, very unlikely to repeat. Your memories are real. This evening is real. The warmth of where you are sitting or lying is real, and all of it is part of a universe that began with extraordinary order, that has been generously unfolding that order into experience ever since, into the experience of light and sound and warmth and thought. Notice how your breathing has slowed a little. Notice how the edges of the day have softened. This is what the evening does. It gathers the energy of the day and lets it spread and settle, like the cooling tea, like the dimming light, like everything that moves from the concentrated to the dispersed. You are part of this. You are, right now, doing exactly what the universe asks of you. We are glad you are here. If this story is helping you find a little peace, please share it with someone who might need the same. And do leave a like. It helps more people find their way to this quiet place. There is a way of thinking about the universe that is called the block universe, or eternalism, and it is one of the most serene ideas in all of philosophy and physics. In the block universe, past, present, and future all exist simultaneously, not in sequence, but all at once, laid out together like the pages of a book that is already written. In this view, the present moment is not special. It is just a location. The year you were born is real and existing, just as this moment is real and existing, just as a morning 20 years from now is real and existing. Time is not flowing. Nothing is changing. The universe is a four-dimensional object, 3 dimensions of space and 1 of time. and everything in it simply is. This is a strange idea, and it takes a little while to let it settle. In our everyday experience, the present feels vivid, and the past feels gone, and the future feels unformed. But in the physics of relativity, this distinction becomes harder to maintain. What is simultaneous for you may not be simultaneous for someone moving relative to you. Different observers cut the block universe into different slices of now. There is no single, universal present moment that all observers share. And yet, and this is the gentle part, the block universe does not remove the arrow of time. Even if all moments exist equally, they are still ordered. The earlier pages of the book come before the later ones. Entropy is lower in one direction and higher in the other. Memories point one way and not the other. The structure of time is real, even if its flow is, in some sense, an illusion. Some physicists find the block universe cold. The idea that everything is already written, that the future is as fixed as the past, that our sense of free will and open possibility is just an artifact of being located in one moment, rather than seeing the whole. Others find it strangely comforting. If all moments exist, then nothing is truly lost. Every good day you have ever had still exists, still is, in the fabric of the four-dimensional universe. Every person you have ever loved still exists in the moments when you were together. There is a kind of quietness in that thought, a permanence. The past is not gone. It is simply there, behind you, real and complete. Every moment of it, every warm evening and every sunrise and every time you felt safe and cared for, it is all still there. You have simply moved on in time, the way you might move from one room of a house to another, leaving the first room unchanged behind you. The philosopher J.M.E. McTaggart wrote about time in a way that has captivated thinkers for over a century. He described two ways of ordering events in time. One he called the A series, past, present, future, always moving, the present always sliding forward. The other he called the B series, earlier, simultaneous, later, fixed relations that do not change, that hold regardless of when you look. The B series is like the block universe. The A series is like the experience of time as flow. And one of the deep questions in the philosophy of time is, which of these is more fundamental? Which of them better describes what time really is? Tonight, drifting toward sleep, you do not need to answer that question. You can simply let it be present, like a warm light in another room. Real, but not requiring your immediate attention. The question of what time really is does not change the fact that evening has come, that your body is resting, that the night is doing what nights do. There is a word in Japanese, ma, that means something like the interval between things, the pause, the space that makes meaning possible. It is used in music, in architecture, in the timing of conversation. Ma is not emptiness. It is the fullness of a space that has not yet been filled, the fertile quiet between notes that makes the notes into music. Time, in this sense, is the ma of existence, the interval that lets things be separate and sequential, that lets stories have shape. Let the silence of this moment be its own kind of ma. Let the space between your thoughts be gentle and wide. There is nothing required of you right now except to rest, to breathe, to let the river of time carry you forward in its slow and inevitable way. Somewhere in the deep ocean, there are creatures that live without sunlight, without the daily rhythm of light and dark that shapes the lives of nearly every organism on the surface. They live near hydrothermal vents, cracks in the ocean floor, where superheated water, rich in minerals, rises from the Earth's interior. In this hot, chemically rich water, bacteria find energy not from the sun, but from chemical reactions. And around them, extraordinary communities of life have built themselves. These creatures, tube worms 12 feet long, ghostly white crabs, shrimp without eyes, clams the size of plates, do not know that time moves forward because of entropy. They do not know about the Big Bang or the thermodynamic arrow, but they live it nonetheless. Their cells metabolize. Their generations live and die. The energy gradient of the vents drives their chemistry, and chemistry drives their lives. And their lives are events with beginnings and middles and endings flowing in one direction. Time visits the deep sea just as it visits you. It does not announce itself. It simply continues. The deep ocean is also a place of extraordinary stillness. In the abyssal plain, the flat, cold, dark bottom of the ocean, sediment falls slowly from the surface world above. A gentle rain of particles that accumulates at a rate of millimeters per 1,000 years. Over geological time, this slow rain builds a record of everything that has happened above. The chemistry of ancient seawater, the remains of organisms, ash from distant volcanoes, the remains of meteorites. It is the ocean's memory, laid down in the silence of the deep. This is another kind of record of time, not memories in a brain, not writing on a page, but the physical accumulation of past events in layers of sediment. Time is recorded in everything, in tree rings, in coral growth, in the isotope ratios in ancient ice cores, in the starlight that has been traveling toward us for 1 billion years. The past is not gone. It is written everywhere in the language of physical change. A geologist reading a column of rock can tell you what the climate was like 300 million years ago, what creatures were alive, whether the area was underwater or on a coastline, whether there were volcanic eruptions or long periods of calm. The rock does not know it is a record. It simply is what it is, the permanent consequence of what has been. This is entropy as memory. Every process that increases entropy leaves behind a trace, a residue of what happened. The spreading of heat, the movement of matter, the chemical reactions of life, all of these leave their marks, and those marks persist. They are, in a sense, the universe's way of keeping a diary. Your own body is a kind of diary of your life. The particular pattern of your neural connections reflects every experience you have had, every conversation, every sunset, every book, every night of sleep. You are, physically, the sum of everything that has happened to you, reshaped and reorganized over time by experience. Your brain itself a record of your personal passage through time. This is an intimate and tender thought to hold as you drift toward sleep. You're not just moving through time, you are made of time. You are a record of it. There is a branch of physics that studies how information is stored and transmitted, called information theory. It was developed in the 1940s by a mathematician named Claude Shannon, who worked at Bell Telephone Laboratories. Shannon wanted to understand the fundamental limits of communication, how much information could be transmitted through a noisy channel without error. What he found was that information and entropy are deeply related. In fact, the mathematical formula Shannon used to define information has the same form as Boltzmann's formula for entropy. This is not a coincidence. It reflects something deep. Disorder and information are two aspects of the same underlying reality. A perfectly ordered system contains no information. It is completely predictable. A perfectly disordered system also contains, in a different sense, no useful information. Every arrangement is equally probable. The most information-rich systems are those that are partially ordered, partially complex, partially surprising. Systems like you, systems like a brain, systems like the beautiful, complicated, not entirely predictable world of a quiet evening. And this gives another layer of meaning to time's arrow. As entropy increases, the universe moves from one kind of information state to another. The highly ordered beginning was, in a sense, information poor. Everything was compressed into one tiny hot state. As entropy increases and structures form, stars, galaxies, planets, life, complexity grows, and with it, information. The universe becomes richer in information as it ages, even as it moves toward greater disorder. Life is the universe's most information-dense phenomenon. A single human cell contains roughly 3 billion base pairs of DNA, a sequence so long that if you printed it out, the book would be taller than a building. And that sequence encodes the instructions for building and running you, one of the most complex physical structures in the known universe. Sleep now is carrying you gently down into one of the most restorative processes biology knows. While you rest, your brain consolidates the information of the day, filing and connecting and gently pruning, making the record of your experience more efficient, more stable, more thoroughly yours. Sleep is not a pause in time's flow. It is one of its most important passages. There is a sentence from the physicist Arthur Eddington that has lived in the minds of scientists and philosophers for nearly a century. He wrote it in 1927, and it named something that had not quite been named before. He wrote about the arrow of time. Eddington was the one who coined that phrase, the arrow of time. He used the image of an arrow not because time is violent or swift, but because arrows have a definite direction. They go one way. And Eddington wanted to capture the fact that time, unlike space, does not let you go both ways. You can move north or south, east or west, up or down. But in time, you can only move forward. Why did Eddington reach for the image of an arrow? Perhaps because an arrow once loosed cannot be recalled. It has left the bow, and it is committed to its direction. There is something irreversible about it, something final and clean. The arrow does not wonder whether to continue. It simply does. This evening, you have been loosing your own small arrows, breaths, thoughts, the gentle movements of your rest. Each one has gone where it went and will not come back. Not because something prevents it, but because the shape of things is that each moment lands and stays where it has landed, and the next moment comes. There is a form of meditation that involves observing the present moment very carefully, noticing each breath, each sensation, each thought as it arises and passes. One of the things that this practice often reveals is that the present moment is, in a strange way, constantly new. Each moment is not the same moment slightly advanced. Each moment is genuinely fresh, genuinely different, arriving and departing. Physicists sometimes describe this in terms of state space. The state of the universe is a kind of point in an enormous mathematical space where each possible arrangement of all the matter and energy in the universe is a distinct point. As time passes, the state of the universe moves through this space, visiting new points, new configurations that have never been visited before and will never be revisited. The universe is always doing something new. This is connected to entropy's increase. If you are moving from lower entropy to higher entropy, you are moving toward more probable, more dispersed, more settled states. And because there are so enormously many more of these states than the ordered states from which you came, the path is always new. You are never merely retracing your steps. In this sense, the universe is creative, not in a supernatural sense, but in a physical sense. It is always generating novelty, always moving into configurations that are literally unprecedented. Every moment, everywhere, the universe is doing something it has never done before. Your life, too, is unprecedented in this way. Not just your life as a whole, but each moment of it. The exact arrangement of your thoughts and feelings and bodily states right now. This precise configuration has never existed before and will never exist again. You are a unique event in the history of the universe, happening once. There is something that feels important about that, though it is hard to put into words. Not importance in the sense of grandeur or pressure. More like the importance of a particular moment of light on water, the way it is completely itself, completely present, not trying to be anything else. The philosopher Henri Bergson wrote about time in terms of duration, durée, which he described as the continuous, unfolding flow of consciousness, irreducible to any series of separate instants. He felt that the scientific picture of time, with its tidy moments and reversible equations, missed something essential about what time feels like from the inside. The lived experience of time, he thought, was something that could not be fully captured by physics. He may have been right, in a way. The arrow of time, as physicists describe it, is about entropy and probability and initial conditions. But the arrow of time as you experience it, as memory and anticipation, as the feeling of being carried forward, as the sense of a life unfolding, that is something richer, something woven through with meaning and emotion and relationship. Both are real, the physical arrow and the lived arrow, the universe's thermodynamic drift and your personal sense of moving through days and seasons. They are not the same thing, but they are connected. The personal experience rooted in and shaped by the physical reality. The way a river both is the water and is the feeling of moving water, both the chemistry and the coolness on your hand. We are glad you are still here with us. If you find yourself drifting, let yourself drift. The story will continue in whatever state of awareness receives it best. There is a flower that blooms only at night. Many flowers do this. Night-blooming jasmine, moonflowers, evening primrose. They have arranged their lives around the cool, dark hours, opening when the daytime pollinators rest and greeting the moths and beetles that move in the velvet dark. These flowers know time in their own way, not as memory or thought, but as a circadian rhythm, an internal clock that keeps time through chemistry. Nearly every living thing on Earth has such a clock. It is one of the oldest biological structures known, so old that it appears in almost every domain of life, from bacteria to plants to insects to you. Your circadian clock is located in a small region of the brain called the suprachiasmatic nucleus, which sounds complicated but is simply a cluster of about 20,000 neurons sitting just above the point where the optic nerves cross. Every day, these neurons reset themselves using light. The light that enters your eyes in the morning sets the clock, and from that point, the clock ticks out the rhythm of your day. And this clock is not metaphorical, it is molecular. Inside each cell of the suprachiasmatic nucleus, a set of proteins form a feedback loop. One group of proteins activates the production of another group, which then inhibits the first group, and the cycle takes about 24 hours to complete. It is a biological oscillator, a tiny chemical clock ticking away in the wet dark of your brain. These molecular clocks are among the most ancient structures in biology. They evolved more than 3 billion years ago when the only life on Earth was single-celled. In those early cells, the clock may have served to keep the machinery of DNA replication away from the hours when ultraviolet light from the sun was most intense. Time, even then, was a resource to be managed. Tonight, your molecular clocks are ticking towards sleep. Melatonin, the hormone of darkness, is rising in your bloodstream. Your core body temperature is dropping. Your heart is slowing. Your brain is changing its activity patterns, moving toward the slower waves of early sleep. All of this is happening because your body has been keeping time all day, tracking the light and dark, preparing for exactly this moment. The clock in your brain does not know about entropy or the Big Bang. It does not need to. It simply keeps time in its own way, the way a sundial keeps time or a pendulum keeps time, through regular repeating cycles measured against the constant rhythm of the world. And here is a beautiful thing. The reason you feel sleepy at night is in part because of the accumulation of a molecule called adenosine in your brain. Adenosine builds up throughout the day as your neurons fire, a byproduct of the energy they use. As it accumulates, it binds to receptors in the brain and creates the feeling of sleep pressure, the growing heaviness, the softening of thought. Sleep, when it comes, clears the adenosine away. By morning, the levels are low again, and you feel rested and alert. This is another one-way process, not entropy in the grand sense, but a daily cycle of accumulation and clearing that gives the day its shape, that makes morning feel like morning and evening feel like evening. You are, right now, in the evening phase of this cycle. The adenosine is high. The melatonin is rising. The day's work is done. Your body is offering you a gift, the gift of sleep, of rest, of the quiet rebuilding that happens when consciousness steps back and the deeper processes take over. Do not resist it. The evening is for this. The biological arrow of time tonight points toward rest. There is a wave that crosses the entire Pacific Ocean, not a surface wave, not the kind that carries surfers, but a deep, slow wave called an internal wave, which moves not at the surface of the ocean, but within it, between layers of water of different temperatures and densities. These waves can be hundreds of kilometers long and move at the speed of a gentle walk. They carry enormous amounts of energy and play a crucial role in mixing the ocean's layers and distributing heat and nutrients throughout the deep. Nobody saw one until relatively recently. They are invisible from the surface. They move in the dark. They cross vast distances over days and weeks, slow and immense, doing their quiet work in the hidden spaces of the ocean. There are, it turns out, many processes in the natural world that take place on timescales we rarely notice. Processes that are so slow they seem like stillness to us, or so vast they disappear into the background of the world we see. The continents are moving, not fast enough to see, but measurably. Europe and North America are drifting apart at roughly the speed your fingernails grow, a few centimeters per year. Over millions of years, this adds up to oceans opening and closing, mountain ranges rising and being worn away, the whole face of the earth rearranging itself in patterns of stately geological time. The stars in the night sky are also moving. The constellation you might see tonight, the familiar shapes of bear and hunter and river, looked different 10,000 years ago and will look different 10,000 years from now as each star follows its own path through the galaxy. The sky is not fixed. It is simply changing more slowly than a human lifetime. The sun is slowly brightening. Over geological time, the sun's luminosity has been increasing as hydrogen is converted to helium in the core. 4 billion years ago, the sun was about 30% less bright than it is today. In another few 100 million years, it will be bright enough that the Earth's oceans may begin to evaporate. This is very slow, far too slow to notice, but it is happening. All of these slow processes are, in their own way, expressions of time's arrow. Each one is irreversible. The continents will not spontaneously return to their previous positions. The sun will not grow dimmer as it was before. The stars will not fly back to their ancient patterns. Everything is moving forward, even when forward is so slow it looks like standing still. This is something that the long history of the Earth teaches us. Patience is built into the structure of time itself. The most important things often happen too slowly to notice. The growth of a child seems slow when you're living it, and astonishingly fast when you look back. The aging of a mountain seems too slow to matter, and yet the mountains are as young as the latest rain and as old as the sea. There is a kind of peace in recognizing that you are part of processes that extend far beyond your individual life. The atoms in your body will continue long after you. They will become part of the soil, part of new plants, part of the air, part of the ocean. They will participate in biological and geological and eventually stellar processes for billions of years. You are a temporary gathering of matter, and the matter itself is not going anywhere. It is just changing form, as it always has, as it always will. The world outside your window is ancient in a way that is almost impossible to fully feel. The soil is full of the remains of creatures that lived and breathed and moved millions of years ago. The rocks beneath the soil are older still. The air itself contains atoms that were exhaled by dinosaurs and breathed by the first forests and scattered by the first volcanoes. Every breath you take is a breath taken from a long, long history. And you are adding to that history now, breathing your own particular atoms into the room, warming the air by the small heat of your body, leaving the soft impression of your rest in the world around you. These are small things, but they are real, and they are yours, and they are part of the ongoing story of matter moving through time. There is a question that physicists call the low entropy problem, or sometimes the past hypothesis. It goes like this. We know that entropy increases over time. We know that the past had lower entropy than the present. But why did the universe begin with such extraordinarily low entropy? This is not a question about what happened. The Big Bang is the answer to that. It is a question about why the Big Bang was the kind of event it was. An event of extraordinary order, of extreme concentration, of very low entropy. Why not begin in a high entropy state? Why not begin in a way that already looks like the far future? Some physicists, including Roger Penrose, have calculated just how unlikely the initial state of the universe was. Penrose estimated that the probability of the universe beginning in such a low entropy state was 1 in 10 to the power of 10 to the power of 123. That is a number so large it has no name, a 1 followed by a googolplex of zeros. It is not just unlikely, it is almost incomprehensibly improbable. And yet, here we are. Here the universe is, existing because of that improbable beginning, unfolding from that extraordinary seed of order, slowly releasing the potential stored in that initial state into the warmth and light and complexity of a universe that can contain life and love and questions about itself. Some physicists accept the low entropy beginning as a brute fact, something we observe but cannot explain further, a given rather than a derivable truth. Others look for deeper explanations, theories that would make the low entropy beginning natural or necessary rather than merely fortunate. One idea, proposed by physicist Sean Carroll and collaborators, suggests that the universe we live in may be part of a much larger multiverse, in which new universes are constantly being created from the vacuum of space, each one beginning with low entropy, each one unfolding in its own direction of time. In this picture, the low entropy beginning of our universe is not a miracle, but a selection effect. We live in one of the universes where the beginning was ordered enough to allow the formation of stars and galaxies and life. This is a humbling and also strangely beautiful idea, that we live in one bubble in a vast sea of universes, each with its own history, each with its own direction of time, all of them unfolding from their own extraordinary beginnings, all of them carrying their own arrows of time into the dark. But the most extraordinary thing, the thing that feels most intimate and most wonderful, is this. In our universe, in this particular bubble of space and time, the low entropy beginning has unfolded over 13 billion years into a world where some of the matter is conscious of its own unfolding. Some of the matter thinks. Some of it asks why. Some of it lies in the dark and listens to stories about itself. The philosopher Thomas Nagel once wrote that it is remarkable that human beings are part of the universe and yet can, at least partially, understand it. The universe, in producing minds, has produced something that can turn and look at the universe and ask where it came from. This reflexivity, the universe knowing itself through the minds it has generated, is one of the strangest and most beautiful things about the cosmos. You are one of those minds. Right now, drifting toward sleep, warm and still and breathing, you are one of the universe's ways of knowing itself. Your curiosity is the universe's curiosity. Your wondering is the universe's wondering. The fact that you find these questions interesting, that you feel drawn to them, that they give you a quiet kind of pleasure, that too is part of what the universe is doing. If this gentle journey has brought you some peace, We would be so glad to hear from you in the comments. And if you know someone who would find comfort in these nighttime travels through science, please share this with them. The Sleepy Science playlist is growing, and there is always more quiet wonder waiting there. There is a concept in physics called time symmetry breaking, and it describes the way that even in a universe where the fundamental laws are mostly symmetric, the actual unfolding of events is not. The universe chose at its beginning to be ordered. And from that choice, or that chance, or that whatever it was, all asymmetry follows. This is true in thermodynamics. It is true in quantum mechanics. It is even true in the weak nuclear force, the one responsible for radioactive decay, where the slight asymmetry of kaon behavior that we mentioned earlier is one small sign of a deep preference in the universe for one direction over the other. But there is another kind of time symmetry breaking that is more personal, more intimate, more closely related to the life you are living. It is the breaking of symmetry between your past and your future that happens in every decision you make. Every time you make a choice, every time you pick up a book or choose to rest or speak or stay quiet, you are converting a space of possibilities into a single actuality. Before the choice, many futures were possible. After the choice, only one actually happened. The symmetry is broken. The many becomes the one. The future becomes the past. This is one of the things that makes life feel weighty and meaningful. We have this experience of possibility collapsing into actuality, of branching paths narrowing into a single road, of potential becoming real. And because it is irreversible, because the road not taken does not remain available as an option indefinitely, each choice carries a kind of permanence. Some physicists who think about quantum mechanics describe the universe as constantly branching, with every quantum event splitting the world into multiple branches, each containing a different outcome. In this picture, called the many worlds interpretation, every possibility is realized somewhere. No road is truly untaken. Every version of every moment that could have happened does happen in its own branch of the quantum multiverse. This is a startling idea. Most physicists do not know whether it is true, but it offers a strange comfort. In a universe of many worlds, nothing is truly lost. Every good moment that could have been is somewhere happening. Every version of you that made different choices is living those choices out. Whether or not the many worlds picture is correct, the certainty of your experience tonight is this: you are here in this moment, on this particular branch of whatever the universe is. And this moment, its warmth, its quiet, the soft weight of your rest, is real. Not one version among many, the actual version, the one you are living. There is a practice in some contemplative traditions of appreciating the particularity of the present moment, not because it will last, but precisely because it will not. The Japanese aesthetic concept of mono no aware, often translated as the pathos of things, describes a gentle, bittersweet appreciation of the transient. The falling of cherry blossoms is beautiful, partly because it is brief. The light of evening is beautiful, partly because the night will follow. Time's direction in this light is not something to be sad about. It is what makes beauty possible. Without the irreversibility of time, nothing would matter. If you could always go back, no moment would be precious. But because you cannot, because this evening will pass and not return exactly as it is. It has a particular quality, a particular light that is its own. You have spent this evening in the company of questions that have occupied the greatest minds in human history. Questions about why time flows, what entropy is, how the universe began, what it means to exist in time. These are not questions that have easy answers. They are not questions that close neatly. They are open questions, like windows left ajar on a summer evening, letting in the breeze of wonder. And that is all right. Not every question needs an answer before you sleep. Some questions are better as companions than as puzzles to be solved. Some questions make the world richer simply by being asked, simply by being carried gently into the night. The night is deep now. Whatever light was in the room is softened. The world outside has settled into its nighttime quiet. The reduced traffic, the cooled air, the sounds of the dark hours that are different from the sounds of the day. You have traveled a long way tonight through thermodynamics and relativity, through the quantum world and the deep ocean, through the block universe and the molecular clocks of living cells, through the extraordinary, improbable beginning of the universe, and the question of why we remember the past and not the future. All of that territory lies behind you now, explored and complete, part of your evening becoming part of your rest. The last thought to carry with you is perhaps the simplest and the warmest. Time moves forward because the universe was born in a state of extraordinary order and has been gently, inevitably releasing that order into the world ever since. The arrow of time is the arrow of a universe exploring all the ways it can be, moving from one arrangement to another, always new, always forward, always leaving behind a record in the warm residue of what has been. And you are part of this. Every breath you take is the universe breathing. Every thought you have is the universe thinking. Every night of rest you allow yourself is the universe resting in one of its most complex and beautiful arrangements. You are not separate from the story. You are one of the places where the story knows itself. The physicist Carlo Rovelli writes about time with particular tenderness. He says that we are time, that our interior experience, the sense of flow, of memory, of anticipation, is not distinct from time, but is what time feels like from the inside, from within a system that is embedded in the thermodynamic world, that is made of matter organized against entropy, that is, for a brief and extraordinary moment, aware. Awareness is what you have right now, in this quiet room, in this soft moment. Not the sharp, attentive awareness of the day, but the gentle, diffuse awareness of the edge of sleep, aware enough to feel the warmth of where you are, the ease of your breathing, the way the world has quieted. The stars, if you could see them, are where they always are, enormous and old and silent, each one a source of concentrated energy, each one slowly unfolding its stored order into light and heat and the gentle pressure of starlight on the faces of far-off planets. The galaxy turns, the universe expands, very slowly, the space between the galaxy clusters stretching over billions of years. Everything is moving forward in the only direction everything ever moves. And you are moving forward too, from wakefulness toward sleep, from this moment toward the morning, from this day toward all the days to come. The river carries you. You do not have to paddle. You do not have to steer. You can simply float the way a leaf floats, turned gently by the current. receiving whatever the night offers. The past is complete. It is whole and settled and at rest. Every moment of it, every version of you that has already been. The future is open and soft, full of possibilities that have not yet collapsed into actualities. And the present, this breath, this warmth, this particular quiet, is the place where past becomes future, where the river bends and the current runs deep and clear. There is nothing to do now but rest. The questions that delighted us tonight will still be there tomorrow, patient and curious and open. The science will still be beautiful in the morning. The universe will still be unfolding its extraordinary, improbable story when you wake. For now, let your eyes be still. Let your thoughts become slow and wordless. Let the weight of your body settle into wherever you are lying or sitting. And let the warmth gather around you. And let the darkness be comfortable. The way darkness is comfortable when you are safe inside it. You are safe. The night is gentle. Time is carrying you forward, as it always has, as it always will, as it carries everything, stars and stones and sleeping children, and the slow drift of continents, and the patient unfolding of the universe itself. Sleep now. Rest now. Tomorrow, the light will come again, as it always does, as it has every morning for 4.5 billion years on this small and beautiful and impossibly lucky world. And when it does, you will be rested, and the day will be new, and the questions will be waiting, warm and patient, like friends who have been sitting quietly in the next room all night. Thank you for spending this night with us at the Sleepy Science channel. Please like this video if it brought you a little peace, and check our playlist for more quiet journeys through the universe. Good night.